All right, so before we proceed to the lecture, so let's go back to the MU886 tab and then the, let's see, module 1 or the assembly language 1 and the lab number 0 and lab number 0. Okay, so do you guys have any questions or clarification so far below this and this one and this one also and with the lab number 0? Questions or clarifications? Okay, so if none, just give me a quick thumbs up because I'll be the ones going to ask later on. That's great. Okay, so let me ask you guys this one. Upon installing the DOSBox and TASM, so were you guys able to make this one work? This code right here, or were you guys able to, finish the video, this one, and then apply what this guy is trying to do? Were you guys able to make this one work? Is it working on your terminals? The DOSBox? Okay, let me ask you guys one by one. John Francis?
Sir?
Napagana mo to? Did you install the DOSBox and TASM?
Hindi ko pa na-install yung DOSBox, yung MU8086.
Okay, sige. What about you, Mr. Mina? Bradley?
Sir, nakikita ko naman yung gumagana po.
Ayan.
Gumagana
No.
po.
What I'm asking is, were you able to make this one work? Or have you installed the DOSBox and TASM first? Itong application na to. Natry mo ba?
Eh sir, na-install ko lang yung DOSBox pero hindi ko pa po na gawa
Hindi
yan.
mo pa na-try. Okay. What about you, Mr.
Wow,
Ramos?
Sir, di ko pa na-install.
Okay. Mr. Mahaba?
So, hindi ko pa rin po na-install. Yung ano pa lang, yung MU8086 pa lang ginagamit ko.
What about you, Mr. Martinez?
Sir, di ko pa na-try yung ano.
So, puro MU8086 kayo lahat. Sa akin, hindi na ako nag-proceed dito because it's not working on my, in my case, maybe in my terminal only. That is why I'm, verifying if it's working on your device. Anyway, Mr. Benlingan. Mr. Kabuwag. Sa
MU86, 8086 din yung gamit ko, sir. Hindi ko pa po na-install.
Kay Mr. Benlingan. How about Mr. Mark Angelo? Ano kaya?
Same lang po, sir. MO8086 po.
Mr. Eliana or Jason, trinay mo ba tong DOSBox?
Sir, hindi po. Yung MU lang din po.
What about you, Miss Paclauna? Have you tried using the DOSBox?
No, sir.
Walang nag-try sa inyo. Sabi ko sa inyo, try nyo muna tong old one. Kapag hindi gumana yung old one, then you can now proceed to the new one. Anyway, so I think that's okay. All right. So before we proceed to the module 2, let's just call this one module 2, the assembly language 2. Do you guys have any questions so far under this tab MU886 and the lab number 0? So I guess none. So let's start now with the module 2. Okay, the assembly language 2, assembly language programming structure. So I hope you guys have already checked this one. Okay. So what's this assembly language programming? Okay. So first, this is statements, or these are just statements that becomes executable when a program is assembled. From the word itself, assembly language, or once they are assembled, or those statements are assembled together, then it can work as a simple program. So this is a line oriented with one statement allowed per line. So we have three classes of statements right here. We have instruction, which is saying that this is a machine instruction in symbolic form. Second one is directives, wherein these are statements gives directions to the assembler. And then we have the pseudo operations. This is a special type of directives that gives the assembler information about data alignment, block and segment definition, and base register assignment. Okay, well, you can just simply focus on directives and pseudo operations. Okay, so directives and pseudo operations is just an assembly program that is consists of 4 blocks or 4 parts, which is called segment directives. And these are the model, stack, data, and code. And then each block is represented by the name model, stack, data, and then code itself after the dat. So this is the first one, the dat model. Second one, the dat stack. The third one is the dat data, and then the dat code. You can include this one as part, but it's not included as the 4 blocks. But this one is needed, of course. Okay, the end message, but it's not starting with that. So in here we have the dat model small, and then the dat stack 100H. So you guys don't need to worry about anything with this one anymore. So whatever you guys are seeing here, it's already it. Okay, you do not change the small into compact, medium, or huge, or any kind of size. Okay, so all throughout of this course, we're going to use small. So small is already enough to run all of our programs, since all of the programs that will be done under this course is short lines of codes. Okay, so hindi naman siya ganun kalalaki. And then second, we have that stack 100H. So this one identifies the area of the program holding the runtime stack, setting its size pointers. So 100H in hexa, or this 100, okay. But this one is in the form of a hex decimal. So again, for this one, you also don't need to change this 100 into any other values. So in other words, the dat model and then the dat stack is already as it is. Okay, so just use a small and 100H all throughout of this course. So the changes will happen under, of course, dat data and then dat code. So that data can be used to define variables and constants, and then the dat code is one holds the executable instructions. So for now, just you guys don't need to worry about what will happen under this certain code. But yeah, here is the structure of a simple assembly language. Saying let's see, simple hello world on a console. Okay, so let's start with the data defining assembly directives. Oops, I missed this one. Again, this is just a note that for all the practice exercises, use model small and then stack 100H. Okay, very, very important. So for the data defining assembly directives, this is the same as defining or declaring a variable. So all directives must be in that data block. So we have 5 ways to define a data. So we have the DB for byte, DW for word, DD for double word, DQ for quad word, and then DT for still quad word, but this one is now like a bigger size. Okay, so you guys will know later on what's the difference between this DT and then DQ. Anyway, for the DB, DW, and DD, so they are very straightforward. It would be easier if we have the notepad right here. So those are our ways of defining a data. Again, word, DB. So for the defined byte, so this one would contain 1 byte or more. Okay. But in other words, it's just containing byte. Okay, if it's more than that, the next one is already word, wherein this one can contain where is it, one or more double bytes. So double byte is 1 word. Maganda siguro pag may limitation. Let's just say that this one is 8-bit. And this one can accommodate 16-bit. And then for the DD is double word. Define word double byte. This is double word. So from 16, just double this one, one word into double word. But of course, we'll now have a maximum of 32-bit. While on DQ, of course, it's quad word. We're just going to, have 4 times of that word. So from 32, we now have 64. 16 times 4 is 64-bit. While the DT is also called the, quad word, but how are we going to differentiate their names? Anyway, let's just say quad word. What when we see DT, this one can contain up to 80 bit. So they come with sizes. So DB is for 8-bit. Okay, that's the maximum that it can store. And DW is 16, DB is 32-bit, DQ is 64, and then DP is 8-bit. So this is the highest, okay, that we can store into a certain cell or location. Okay. Now we have some examples here wherein DP or defined byte user allocate initialize one or more bytes of data. So we have the variable name and then the defining function, which is in DP form, and then the initial value, and then up to how many values you want. Okay, you can put in there. So let's say this is your variable name mem db, and then we have let's say 3 initial values right here, wherein all of them are of course in hexadecimal. So 35h, 0fh, and then 60h. Okay, so if you're going to put this one into a, let's see, memory or register, here's the first one, 35h, 0fh, and then 6dh. Okay. And if we have double defined word, okay, not double word, okay. So this one now is now 6, it can accommodate up to 16-bit. Okay. So we could now have 1, 2, 3, 4. Okay, 4 characters instead of 2 only, because it's now like double byte of this one. Okay. So if we are going to put this one into a memory, still this memory cell can only accommodate up to 8-bit. Okay. So going back to the first one. So you guys will see here that, for the EX, VX, EX, DX, this one can accommodate 8-bit and then 8-bit only. Okay, or let's just say a maximum of 16 bits, since it says here that 1 or more bytes, but in reality it's just up to 2 bytes. Okay. So if we are going to convert this hexadecimal to binary, where's that one? Let's see, 35h. 35. Okay, so we have 8-bit. Okay, maximum. Okay, so that is the conversion for the 35h, and then for the 0h, same. We also have 8-bit, 4-bit only. Okay, so 1, 2, 3, and then 4. Okay, but of course, it's considered as one cell if you're going to include the 0. Okay, we have 0, 0, 0, 0 right here, and then F is the 1, 1, 1, 1. So do you guys have any idea how did we come up this 1, 1, 1? Alam nyo? Don't tell me you guys don't know how to convert, let's see, decimal to binary or binary to hexadecimal yet. Okay, let me call someone. Mr. Ferreras, do you know how did we come up with this 1, 1, 1, 1? From this 0f hexadecimal into binary?
Alam sir, pero di ko natanda rin. I-refresh lang po.
Yeah, Okay, so it's actually 842. F is actually equal to 15. Okay, maybe I need to refresh you guys. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's starting from 10. Okay, it's already A, B, C, D, E, F. Okay. So 1 to 9 is as it is. It's 1 to 9, but this one is 10 already. 11, 12, this is 13, and this is 14, and this is 15. Now these are, let's see, the decimal values and then up to the hexadecimal values. So if we're going to convert this F into binary, okay, so say we have 8 bits, okay. The first value right here, kasi, muna tayo. The first value right here on the right side has a value of 1, followed by this one is 2, followed by the third one is 4, followed by 8. Okay, so 1, 2, 4, 8. Okay, so we have here 1, 1, 1, 1 because we have to activate the 1, 2, 4, 8 to come up with the value of 15. So 8 plus 4 is 12, plus 2 is 14, and then plus 1 is 15. And then it doesn't show the 0 right here anymore because, of course, this is just the 0 value. That is why I'll remove this 1 and we'll just still simply give us this 1, 1, 1. Okay, but if we have 1 right here, let's say 1F, then we have to activate this 1. So it will give us a value of 0, 0, 1, and then 8, 4, 2, 1. Well, anyway, just maybe just need to refresh, okay, your knowledge regarding the binary system. So that's how we've come up with this 35H, 0H, and then 60H. And then again, our cells or memory location can only store 1 byte. Okay, 1 byte is equal to 8 bit. 1 byte is equal to 8 bit. Okay, so bit is this one by one. So in here we have a total of 8 bit. So even though we have already defined this one into a word, wherein word is equal to 1 byte. My bad. 1 word is equal to 2 bytes. Okay, so we have a total of 16 bit now from here. So even though we have already here a double word or a 16-bit individuals, we still have to save this one by 1 byte. Okay, so you're going to save this one, let's say 0F right here, and then 35 right here, 45 right here, and then 60 right here. Okay, so we cannot store a total of, let's say, 16-bit in one cell. That is because we can only store up to 8-bit because of this, storing of memory, something like here. These registers right here. So 8-bit, 8-bit only. All right. So this is just a double word wherein, of course, we can now have 0F35H. And if we're going to convert that one into 0F35H, it will give you a total of 16-bit in total. So the same with 456D H. Okay, so H is just an indicator that saying that this one is in hexadecimal form. Okay, while in the defined double word, well, of course, this double this defined word right here from 4 characters into 8 characters. We now have 1, 2, 3, 4, 5, 6, 7, 8. Then again, however, even though we already have this one defined into a double word, if we are going to store that one into a memory, it can only store this one by 1 byte. So 35, 0F, 60, and then 45. So we are now similar with this double word. Okay. And then for DQ, wherein of course from 32-bit will give us a maximum bit of 64-bit. So from 8 characters, this one now has a total of 16 characters. And again, regardless of how many characters we have in here, we can only store 1 byte each cell. So we can have this one upon storing those characters or hexadecimal values. Okay, so 35, 0F, 60, 45, etc., etc. While on the other hand, so this is the largest that we can store. Let's see, define quad word. So this is an example. memDB. So this is an uninitialized. Okay, so we can actually put a question mark. We are already taking a certain storage, but we don't know the value yet. Okay, so it's like that's the meaning of uninitialized value. Okay, so these are initialized value. You already know the values of what we are going to store in this memory or register. But if it's question mark, then you can just simply say that they are 0, 0 for now until already given has, or until it was already overridden by a certain value. Okay, pag may dumating ng bagong value, or once it's over written by a certain let's say variable, and that is the only time that could have a real value. Okay, so that's it for DB. Okay, so from 64-bit, just add 8, 16, just add 2-bit, 2 more bit. Tama ba? 70. 4 plus 8. Then nadagdag dito. I just got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's an additional 2 bytes, okay, for the DB. And then we have here again the uninitialized value, wherein this one indicates a value that assembler allocates, but does not initialize, so it can be used alone or with dupe or duplicate. So we have here the simplest example, wherein we have a variable mem or label mem. So this is a double word. So meaning if it's double word, if it's just one, then it would get at least 2 bytes. Okay. So let's see the first 2 bytes. It's DB. How about DW is double word? Defined word, sorry. And then DB is defined byte. So defined byte is just 1 byte. So we have 3. So it will going we're going to get 3 cells right here. And then for the DB, so we have 20, okay, 20 cells. And then you're going to duplicate this one, which is has an unknown value. Okay, so initially, of course, if it's an unknown value, it will not duplicate this 20 characters yet. So initially, it will accommodate 20 cells. But if you put here 1, okay, you're going to duplicate this one by 1. Okay, so 20 times 2 is like going to have 40 cells right here. Okay, anyway, so maybe you don't get what is this dupe yet, since we haven't discussed this dupe. Okay, let's now discuss that dupe or duplicate. So again, this one initialize several locations and to assign values to this location. So also used to store repeated patterns into larger variables and buffers. So we have 2 examples right here, wherein we have this variable name ARR, double word, 5 dupe, and then 0. So in here, we have a double word, okay, meaning we are going to accommodate at least 2 bytes, okay, for each of this cell right here. So are you guys getting the idea of this double word or double byte? Nakuha nyo ba kung bakit and why we're having 10 cells right here? Okay, so this one allocates 5 words and initializes all 5 words with 0. Again, 1 word is equal to 2 bytes, right? So in other words, 1 word is equal to 2 bytes. Okay, so that is why we have 10 cells right here, because we need 10 bytes for these 5 words. Because then again, 1 word is equal to 2 bytes. So were you guys able to follow on how did we get these 10 cells of ARR right here? Okay, that's good. Now for the double byte, since double byte, why do I keep on saying double byte? DB, defined byte. Defined byte is just 1 byte. Okay, so meaning we're going to duplicate this one, okay, 5 times, or in a 5 set. So we have 20H for the first byte, and then 40H for the second byte. So we have the first set, Okay, that is the first duplicate, second duplicate, third, and then fourth, and then fifth duplicate. Okay, so if we have three, let's see, values, right? Let's say 20H, 40H, and then 60H. Then from 5, it will become still set 5, but we'll have a total of 15 cells in total. Okay. So anyway, so 20H is already getting the first byte, and then 40H is already getting the second byte. So a total of 10 cells in total. So were you guys able to follow on how did we come up with this, values in these registers or cells for this defined byte? All right, so next is the PTR or pointer. So this one defines the size of operand or distance a reference have. It is used to override the default type for one instruction. So in here, just simply passing the value of this variable into another variable. Okay, so we have this one as an example. So assume value is a word, wherein of course a word is 2 bytes, and then we have 4, 4, 3, 5 each for this one word, and then we have this code move value. So it will give you an error because again, this right here, where is that one? Okay, can only accommodate up to 8 bits or 1 byte only. Wherein you're going in here you're trying to transfer a 1 word into a 1 byte. Okay, or a 2 bytes into a 1 byte. Okay. So you cannot do that one. Okay, you can only move a certain value if the location is larger from the original size that you're going to transfer. Okay, so of course you cannot fit 2 byte into 1 byte. Okay. So to make this one work, you can just simply use pointer. Okay, wherein it's you're still moving that value into that but you're only getting the most significant bit. So when we say most significant bit, you're only getting the left. Most significant bit is the left side. Bit furthest to the left. Yeah. Okay. So it is the most left side data. Okay, or character. So in here, as an example, move by PTR value, it will give you a result of 35H. So even though you are trying to store this 4435H, okay, on the most left side, wait, tama ba? My bad. Okay, this is not the most significant bit. This is the least significant bit. Okay, so for the first one, it's the least significant bit. If it's the most significant bit, it is the second one. So it's the other way around. So for the first one, it's the least significant bit, wherein you're getting the first 2 characters on the right side. Okay, so we have here the result of 35 each. And then the only difference between these two is that this one has a +1. Okay, so from let's see, least significant bit, maybe just adjust 1 byte. Okay, and then you are now getting the next byte, which is the 44H or the 44H. Okay, and then if you can try to make this one work on the MU886 value +2, meaning you are moving 2 bytes from the least significant bit and then getting the byte after those 2 bytes. Okay, so are we clear so far regarding with this one? Are you guys getting the idea of this value and then value +1, or maybe value +2? What about the others? So I hope we're really clear with this one. If you guys need more example, we can have one example for this one. Pero mukhang wala namang question. Anyway, so the last one na ba to? Okay, second to the last is the offset. So this one is used to load the offset of memory location to a pointer register. Okay, so in here it's just saying that before we can move something else, so it will also accommodate a certain memory. Okay, so for example, that data num DW 0F012H, we have this one wherein we have moved SI offset num1. So the offset is the distance of num1 from the start of data segment of num1 is loaded to SI, and then SI will be used to access 0F12H. So in order for you to transfer this one, or let's say access this one, of course you have to store this one first. Okay, so let's say this is where you're going to start store that one, starting from the start up to the 005. Why up to 005? Because it will save these characters one by one on this cell. So 0, F, 0, 1, and then 2. Okay, and then if you're going to access that one or save that one into, let's say, num1, then of course it will now accommodate another 5 cells. Starting here, we have 0, F, 0, 1, and then 2. Okay, so yeah. So this is an abstract illustration of the example SI will now have the value of 5. Okay, because that's the counts of characters that it accommodated according from this example value. So if you have 4, then it will have a value of 4. If you have 3, then it will have a value of 3. Okay. And then EQU is as simple as equate. Okay, this one is used to assign a constant or a variable or an expression to a variable. So equal or equate is used for numeric values only. Okay, let's see, count is EQU 10. Okay, this one now has a value of 10. Then equated symbols are not variables. Okay, so this is not a variable, and this is just, you could consider this one as a symbol maybe. Okay, so this element now has a value of 5. Then EQQ expressions are evaluated where use or equal expressions are evaluated where defined. So for example, my string EQU and then hello. So this one now has a value of string hello. Okay, or you can use the symbol itself. Okay, this equal sign. So it's similar with this EQU variable expression rather. Okay, so this size now has a value of 0. So are we clear so far for the EQU? I think this is the easiest function that you guys could understand, since you're just simply equating or giving a value of of a certain variable. So are we clear so far up to this number 10? Or we proceed to the data item attributes. Some questions or clarification? All right, so it seems that there is no more questions. We still have 1 minute and 20 seconds. So let's try to finish this data item attributes. So we have 3 attributes. We have the type, the length, and then the size. So for the type, we have this one. See, this is the type 1, wherein it's the bytes. Type 2 is a word, and then type 3 is double word, or we even have the type 4 and type 5. Type 4 is the quad word. Okay, and then type 5 is also a quad word, but this one is the DB, the one that has or that can store 8 bit. Okay, so all in all, we have 5 types of attributes. Okay, so I hope I'll be clear with this one. And then length is the total number of building blocks that make up the data item. So we'll explain this one furthermore with these examples. And then size is number of bytes reserved for the data item. So correction regarding with this one, 200 words is not equal to 500, but 200 words is equal to 400 bytes. Because again, it's 1:2. Okay, 100 words is just 400. Okay, so just change this 1 into 400. So we have some examples right here. So variable temp, double word, 200, duplicate, and then you don't know what is a value yet. Okay, so the type of this one is double word. Not double word, defined word, my bad. Apologies regarding with that one. So this is the